Hello everyone, welcome back to the series on ImageJ. Today we are going to talk about slightly intermediate to advanced analysis called as the particle analysis. Now particle analysis can be used in many setups. Since I am a histopathologist, I am putting forth two images here. Now on the right side you can see a tumor, and my idea is to count the number of cells present inside the tumor. On the left side, you can see these specific pink colored cells. These are the eosinophils. I can even threshold the images to actually count the number of eosinophils in this background. So all this can be automated. So in terms of the objectives, I will demonstrate a step-by-step workflow of the particle analysis using ImageJ, and I will tell you how thresholds are done. Now, if I go back to the image, you will appreciate that there are areas where there is an overlap. You can see that there are cells which are overlapping. So how do we exactly measure or analyze the overlap? The overlap can be analyzed by using binary separation methods. In this case, I will show you a method called as watershed method, where you can analyze the overlaps accurately. We'll also configure the analysis settings to obtain some quantitative data like the area of the cells, circularity parameters, etc. So let's dive into the process. So here is my ImageJ software. So let's go to my image. Let me take the image on the cancer tumor. So like you see here, I have opened both the images. Here's my first image. Let's do the first image first. The first step is to localize my area of interest. So here is my tumor island. Okay, so I'm marking the tumor island. I want to look at the cell density in this tumor island. So I can go to edit. I can clear the outside so that all the noise gets cleared over there. I can even crop the image a little. So you can go to image and crop. So it becomes apparently the right size. Then we go to 8-bit image conversion. So binary processes, that is ones and zeros, which the computer understands, is possible best with the binary images. So here you have an 8-bit image. Basically, it becomes a grayscale. So now I can go to thresholding. So we can go to image, adjust threshold. The shortcut is Ctrl-Shift-T. And there are many methods of thresholding. Usually we have an OTSU method, which is pretty good and decent in analyzing and separating these thresholds. So as you can see here, it's kind of thresholded it very well. So it's a semi-automatic thresholding. Although I'm using the computer system to do the thresholding, but you are having full control over the analysis. So you can actually semi-automatically threshold it. You apply it. Once you apply, you have created a mask. So you can see that there are a lot of cells that are kind of round, there are smaller particles, etc., etc. So next step would be to analyze. So let's analyze these particles. It goes under the heading of analyze particles. Now before this, I have to work out on the overlaps. So we go to process and binary. And if you see here, there is a process called as watershed. So let's have a look at the image. Let's focus on one of the images here, which is 2 or 3 big elements joined together here. So let's click on watershed and see what happened. You basically have separated that big unit into cells, individual cells, which is pretty decent for the amount that has come up. So let's go to analyze and go to analyze particles. Now here there are 2 headings. One heading is the size of the pixel. So if you observe, the smaller ones are not cells. They are just aberrations, some maybe a blue dot or something that has come up. And the circularity is whether they are circular, they are linear, etc., etc. You can always exclude on edges so that the cells in the edges which are not complete gets excluded. And you want a summary. You want to clear the previous results. And what do you want to show? I want to show the outlines. Or I want to show which particle is which size. So let's click on OK. And you realize that there are a lot of particles that have come up here. So let's zoom into this. You can see that this small area has so many cells, which I don't like. So we have to adjust. So here it is showing you 432 particles, right? And you can see that there are particles which are 1 pixel, 2 pixel, 3 pixels. So if you look at this, I don't want any of these which are under 500. They are not my cells. The cells are much larger. So it's ideal to have a look at the area here and try to figure out above what size are my cells. So the way I look at it, most of my cells are about 1000. So if you look at this, most of my cells are about 1000. So once I get that idea, I can actually go to analyze, I have to select the image. I have to go to analyze particles. And instead of 0 to infinity size, let's make it 1000 to infinity size. And say okay again. Now you see that it is much more clearer. You can see all the particles above 1000 are getting selected over here, right? And then when you look at the summary results, you can see there are 197 cells present inside this particular area of my tumor. Kind of gives you a very good cell density. Now your next question can be, can we use this to measure the size of the cells? Yes, of course. So what you can do is go to analyze and set measurements. There are a lot of measurements that you want. Let's say you want to measure of the perimeter, you want the centroid size, you want to measure the ferret diameters. So there are many other elements which you can explore and you can set it. Once you set it, let's do the analysis again. Let's go to analyze particles and say, okay. Do you want to save the previous measurements? No, I do not want to save it. Now, if you see it, 197 remains the same, obviously. But if you see the individual measurements, you will be able to analyze the various other parameters like perimeter, ferret, ferritex, etc. So that was about the particle analysis. So I demonstrated to you a step-by-step workflow. I showed you an appropriate thresholding and binary separation watershed method. And you can configure your particle analysis based on the size and also we apparently show the various measurements. So that was about particle measurement. So feel free to please answer the MCQs that follow. Best of luck learning imaging and use it for your research purposes. Good luck.